Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in science, engineering and architecture subjects. Today in our playlist of electrical engineering, we'll understand the protection of three-phase induction motor and we'll learn how the most widely used electric motor in industrial drive is protected by various faults to ensure safe, reliable and efficient operation. So let's start. Overload, short circuit, earth fault, single phasing, reverse phase sequence, protection of three-phase induction motor. Such three-phase squirrel cage induction motors are widely used in industry and agriculture to meet various requirements of those sectors. Almost 100% agriculture pumping sets are driven by such three-phase induction motors, and majority of industrial drives are operated from such three-phase induction motor. Now the safe, efficient and uninterrupted operation of such motors is utmost important for reliable and efficient operation of industries or agriculture pumping. In a motor, fault is a condition due to which motors start working somewhat abnormally and many a times it fails to even work. We can classify these motor defects or faults into two: external and internal categories. External fault include unbalanced supply voltage to motor terminals, under voltage condition in motor supply, the reverse phase sequence condition in motor supply, or single phasing in electric supply. So these all external faults are related to supply conditions, whereas motor during operation may have some internal defects and they may be mechanical bearing related failures, overheating by internal losses or lack of ventilation, winding failure, or many a times some conductor part get connected with non-conductive grounded structure called as earth faults. So we'll learn first all type of fault and defect in motor operation, and then we'll study how motor is protected against those fault conditions. External faults are related to power supply conditions which are supplying electricity to three-phase induction motor, and they may include unbalanced voltage, under voltage condition in supply, single phasing, one phase is not available for motor supply, or reversal of phase sequence for the motor. So let's understand all these external faults one by one and their effect on motor. So one is unbalanced supply voltage. This will occur when three-phase supply got unequal magnitude or other than 120-degree mutual phase angle, and in that condition if we analyze unbalanced supply voltage, it would have a negative phase sequence component, and that negative phase sequence component generate a reverse rotating magnetic field that will have higher value of slip 2 minus s on rotating rotor winding of induction motor, and that will cause excessive rotor current, rotor losses that also get reflected in stator current and produce stator copper losses. So these losses generate heat and torque pulsation and reduce efficiency of motor, and if this voltage unbalance is small, less than 1%, the effect on motor losses and motor heating as shown by respectively black and red curves is small. But if unbalance exceed by amount of 2% or more, we will get that there is a significant increase in motor losses and motor temperature rise. And if unbalance in supply become 5%, then it will increase motor heating by 50% additional amount, and we have to derate motor operation for safe operation in such unbalanced supply voltages. Another common problem with three-phase induction motor operation is under voltage condition of supply. Now this under voltage problem occur when supply voltage magnitude drop below the rated value, and to produce the required amount of mechanical output power, motor draw the same electrical input, and at reduced line voltage condition, motor will draw more line current, and this will increase motor full load amperes, and a reduction of 10% amount of voltage will increase motor full load ampere by 10%, and increased ampere will produce increased heating losses, temperature rise and reduction in operational efficiency. At the same time, reduced voltage would have reduced air gap flux conditions, and this will reduce the torque produced by motor, and that will enhance slip, rotor copper losses, heating, temperatures rise in motor. So under voltage conditions, if continuously persist with a good amount of reduced voltage conditions, will overheat motor and may damage it. Phase sequence in three-phase supply is order of lead or lag among three phases, and here R leads B and B leads Y. So it's a RBY phase sequence, and if we exchange any two supply wires, the phase sequence will reverse as it is RYB now. Now in a three-phase induction motor, in stator, winding of three phases produce their magnetic field at three different electrical 120 degree displaced axes, and when we supply three-phase time displaced excitation to three-phase space displaced winding, it produces a rotating magnetic field of constant magnitude and constant synchronous speed, and the direction of rotation of magnetic field is from magnetic phase axis of leading phase to magnetic field axis of lagging phase. So when phase sequence is R, B, Y, then rotating magnetic field will rotate from R to B to Y and then again R in anti-clockwise direction. And if we exchange any two supply wires, then phase sequence will reverse as RYB, and now from leading phase axis R axis, the rotating magnetic field will rotate towards lagging phase axis, that is Y. So the direction of rotation will become clockwise. So by change of phase sequence, we can change direction of rotation of rotating magnetic field and then the direction of rotation of motor rotor. And if in certain applications like lift, crane, hoist, trams, direction of rotation reverses, all of a sudden it will damage the load and motor. And this problem is also there in pumps, fans, conveyor belts. So we need appropriate protection against opposite phase sequence conditions so that motor should not rotate in opposite direction all of a sudden. Single phasing is a condition that occurs when one of the three phases that supply electricity to three-phase motor loads its supply connection, and loss of current in one supply phase is described as single phasing in operation of three-phase motor. And a stall three-phase induction motor won't run in single phasing condition, but a running three-phase induction motor will continuously run even in single phasing conditions with two supply line supplying electricity to delta connected induction motor. Now to deliver same mechanical output, motor draw same electrical input, and when in place of three-phase supply, it will have only single-phase supply between two lines with line voltage VL. The motor will increase its line current to maintain same amount of mechanical output, and sometimes with such single phasing condition, the motor power factor also decreases. So line current will increase from root 3 to 2 times in single phasing condition into remaining lines, and phase current in one phase winding may become even more than double in such single phasing conditions. When contact of one of supply line unintentionally opens or supply line of one phase fails, a running three-phase induction motor continue its rotating action but with reduced speed and increased vibration, and one of the phase winding will have 2.3 times normal current. When line current has increased to root 3 to 2 times, the normal overload relay may protect motor from such single phasing conditions, but if motor is underloaded and line current won't attend relay operating current conditions to ensure overload protections of motor, one phase winding due to excessive current in it get overheated, and that is a potential damage to motor winding. Single phasing condition also reduce operating torque of motor, increase slip, and affect motor performance and its lifespan. Now it is time to understand internal defects and faults in an induction motor. Internal faults are those faults which arise from motor itself or from driven part which is connected to motor. And internal faults includes bearing failures, overheating in motor, winding damage and failure, and earth fault in motor winding and conductive parts. Bearing failure in an induction motor takes place when bearing supporting the motor shaft get dried out, wear out, or even seize due to friction or lubrication problem or mechanical stresses or unbalanced conditions. Friction, vibration, and misalignment can cause mechanical wear and tear, noise, vibration, shaft misalignment, and even motor stalling condition, and that lead to premature motor failure because in stall conditions motor draw 4 to 8 times normal full load current, and that current may cause excessive overheating of winding and damage its insulation. So bearing failure also results in overloading of motor, burning of winding insulation, and it is historically found that bearing failure accounts for 13% in total motor failures. Overheating of working induction motor is most common failure in three-phase induction motor, and overheating occurs when the temperature of motor exceeds its safe thermal limit due to overloading, inadequate cooling, hot ambient conditions, or some breakdown in insulation. Such overheating will cause insulation degradation, winding damages, and they also reduce motor efficiency as increased temperature would have higher winding resistance and copper losses. Now, to safeguard motor against overheating, it is necessary to analyze the load conditions and to ensure that motor is selected of a proper size, and during operation it is never overloaded. We have to also assess the ventilation systems to ensure adequate cooling air flow around the motor, and for that we have to keep motor and its surrounding area clean, and we have to prevent all sort of dust, dirt, or other accumulations. To reduce friction and unnecessary mechanical loading, we have to ensure proper lubrication of all moving parts for smooth operation and cool operating conditions. So, against overheating failures, we have to implement a system that should monitor motor temperature and issue alerts for all overheatings. Two important winding failures are one winding get short circuited and other winding get open circuited, and both takes place by insulation breakdown or temperature rise or mechanical stresses on motor winding, or some external faults may create condition of short circuit or open circuit, and such winding failure can cause spark, excessive temperature rise, smoke, even fire, and a motor with winding failure can't produce rotating torque during operation. In motor operation, unexpected voltage spikes of supply can stress insulation, and that lead to premature failure in winding insulation and create problems of either short circuit or open circuit in winding. Contamination like moisture, dirt, dust can compromise the property of insulation, and that cause winding failure. Excessive heat is one prominent way that degrade insulation material and leading to short circuit and failure in winding. The common symptoms of winding failure are unusual and loud noise during motor operation. Significant temperature increase is another symptom of winding failure. When winding failure takes place in a motor, the variation in motor speed and torque also takes place, and sometimes we can even see visual damage in winding by winding failure. Earth fault is another internal motor failure during operation, and earth fault occur when a phase conductor of motor carrying current comes in contact with grounded part of motor and driven equipment. We can say earth connection is unintended connection between electric supply circuit and earth ground mass, and this result in a high fault current in certain motor section that can overheat and damage motor insulation, and if proper earthing of non-conductive motor enclosure is not done, it may cause a shock hazard to operating personnel. Motor faults, whether they are external connected to supply system or internal connected to motor operation, all affect the performance, safety, and lifespan of motor operation and its allied circuit and driven equipment. So it is very essential to detect and protect motor and driven equipment from all sort of motor faults. A motor protective device monitor and control parameter such as motor line current, the voltage of supply, temperature condition of winding and other critical motor parts, speed, vibration, torque conditions, and by that monitoring and control, it prevent or minimize the damage to motor and allied driven system in the event of fault or abnormal conditions. The motors are protected against breakdown in winding insulation, excessive overloading, short circuit, temperature rise, under voltage, reverse phase sequence, unbalance in supply voltage, single phasing, and we'll study all those protections one by one in next few minutes. Overcurrent in motor operation occurs when current exceed the rated current specification of motor or the ampere capacity of motor winding conductor. Such overcurrents may occur due to overloading or faults like short circuit or earth fault. Overload is the operation of motor where it draw current excess of its normal full load rating. Any motor can withstand small amount of overload up to 30% of normal full load current for small time interval, but if such overload persists for a longer period, say 20% overload for half an hour, it will cause damage to motor by temperature rise of overheating. Such overloads will take place if motor is undersized, the mechanical load on motor is excess in amount, or a motor is supplied from a source which provide lower voltage than the rating specification of motor. So in under voltage condition, motor draw extra current and that cause heating in winding by increased copper losses. So a overcurrent relay continuously monitor the current drawn by the motor, and such overcurrent relays are connected in series with motor lines, and if they found current more than the specified values, they issue a trip signal to contactor circuit, and that ensure safety of motor operation. Most of commercial motor got a thermal bimetallic strip overload relay which have an heating element which operate from motor line current, and when current exceed predetermined value, say 115 to 125% of full load current for a specified time conditions, the thermal bimetallic strip element bends, and that cause auxiliary contact of contactor circuit to open, and that operate contactor to disconnect supply from motor. Such thermal bimetallic strip type of overload relays are very simple, cheap and reliable devices, and they have a inverse time protection characteristic. That means they trip faster in smaller interval if overload exceeds. That means for 25% of full load current, if it trips in 1 hour for 2 times of full load, class 10 type of motor will trip in just 30 seconds. However, such thermal bimetallic strip type of overload relays are quite slow to respond and cannot provide appropriate protection against short circuit currents or ground faults which may exceed 50 to 1000 fold of full load current. The accuracy and repeatability of overload thermal bimetallic strip are also limited due to mechanical wear and tear. Short circuit is a failure of winding insulation that create unintentional electric connection between two sections having considerable voltage and negligible impedance. And ground fault is an unintended connection between electric circuit of motor winding and non-current carrying part of motor like core or metal raceway or equipment enclosure or earth structure. And in both conditions, whether it is short circuit or earth fault, the motor current in some section of winding may become excessive dangerous, and motor circuit should be protected by a fuse or circuit breaker. When a motor have earth fault and its body is not properly earthed, then in those conditions dangerous shock voltage may exist on metal parts of motor, and that may cause electric shock to operating personnel in case of earth faults. And if motor is properly earthed, then earth fault get converted into a short circuit and excessive current condition, and fuse or circuit breaker will act and disconnect supply from motor. Thermal bimetallic strip overload relay protect motor against overloads, and fuse and circuit breaker acts as motor protective devices against short circuit or earth fault conditions. Fuse interrupt the circuit when motor operation have a fault of short circuit or earth fault. Fuse basically consists of a metal strip or wire which for normal current conditions, say this fuse rated at 32 ampere, won't get heated up, and this fuse element at 200 ampere conditions won't get heated up. But if current exceed many times of this full load current, that metal wire or strip get heated up by fault current and will break supply to motor. These fuses are simple, cheap, reliable, that provide direct fast acting protection against all sort of short circuit and earth fault overcurrents. However, such high rupturing capacity fuses are not reusable and they need to be replaced after every protective operations. Fusing factor of commercial fuse is 1.1 or even more. That means normal rated current, say 32 ampere in this fuse, won't produce heating in fuse element, and for fusing action at least current more than 1.1 times of this rated current is needed. So such fuse won't provide protection against small overloads or problem caused in motor by under voltage conditions. Circuit breaker or contactor got pair of contacts for 3 line supplies, and that open and close by an electromagnetic and mechanical mechanism triggered by a sensing relay element and operated by a spring action. Such circuit breaker got reusability and resettability. Some good quality contactor with appropriate sensing relay can provide required protection against overload or under voltage conditions. Sophisticated electric motor drives or high size motors are protected by electronic, digital or numeric overload relay, and such relay circuit use current transformer or shunt resistor that measure motor line current, and inherent microprocessor and solid state circuitry get that reduced feedback current, and as per internal programming they control the contactor, and when current exceed a predetermined value and a predefined time interval, the digital logic circuitry sends signals to open or close contactor for appropriate protection. Such digital or numeric overload relay provide fast response and high accuracy and very good repeatability due to their digital processing. They have additional inbuilt features such as single phasing protection, reverse phase sequence protection, and they also provide remote control, telecommunication and telediagnostic services. Differential protection relays are the devices that compare the current in input and output terminal of motor winding, and if there exists a difference between the two currents exceeding a predefined certain value, then that indicate the problem of winding fault and issue trip signal to contactor circuits. Such differential protection relays are very sensitive and reliable devices that provide rapid protection against phase-to-phase and phase-to-earth faults in motors. For small size LT motors, typically less than 75 kilowatt, such contactor control circuits are used for motor protection, and in motor circuitry, contactor, thermal overload relay and fuse provide complete protection against all sort of faults. This series fuse provide protection against short circuit and earth fault conditions, and this thermal overload relay provide protection against overload conditions, and we can also use special differential relay protection for earth fault protections. This is power circuit of contactor control circuit, and this is control circuitry for the same contactor circuit. For protection of high kilowatt rating LT motors or sophisticated motor drives, such numeric relays are used for all sort of motor protection. In this numeric relay, settings for different protections are incorporated in its microprocessor programming. and such relays are tested to ensure that all protections are provided during motor operation. Most of such microprocessor based numeric relays are programmable and we can program them as per our protection needs. For protection against undervoltage operation of three-phase motor, simple thermal bimetallic strip overcurrent relay can be used as motor draw excessive current when operated on undervoltage conditions, and overload device act and provide protection for such motors for undervoltage operations. The phase reversal of three-phase supply is quite dangerous in certain motor applications such as elevator, crane, hoist, trams, or even in pump and fans, because reversal of phase sequence will reverse the direction of rotation of motor and allied drive components. And to ensure protection against reverse phase operation, we will use phase sequencer relay, and in case of reverse phase conditions it will issue trip signal and contactor will disconnect supply from motor. We know that in single phasing conditions a running three phase motor keeps on running, but it will draw extra current in one part of winding and which can burn the motor, and such problematic conditions won't get noticed in line current, and normal overload protection won't provide protection against single phasing conditions. So we need a electronic single phase preventer that monitor the power supply and ensure that all three phases are present to supply motor, and if there exists single phasing condition it will issue trip signal to contactor coil and that disconnect supply from motor. Relay based single phase preventer use relay circuitry that detect single phasing and activate the protection mechanism that disconnect supply from motor in case of single phasing. But popularly we use an electronic single phase preventer that utilize a dedicated electronic circuit that monitor the three phase availability, and in case of single phasing the negative sequence current or voltage imbalance can provide required trip signal to contactor, and that automatically disconnect power to the motor and provide protection against single phasing. And when normal power again get restored and all three phases are available to motor, the preventer automatically reset itself and allow the power supply to get connected through the motor to resume normal operation. So as summary, we can say electric motor protection is very important as it prevent all costly damages, as when we detect and mitigate all problematic issues of faults before they escalate and cause economic consequences in motor operation. Appropriate motor protection enhance safety for operating personnel by reducing the risk of all electric hazards and other accidents. When we have a sound motor protection system, it prevent frequency of motor failure and ensure continuous operation of motor and allied drive that maximize operating efficiency of industrial and commercial processes. So motor protection is very important for safety, reliability, efficiency and economy of motor operation. It also enhances working life of motor and allied component. We hope this long but very beautiful and informative learning video has explained each and every part of faults in three-phase induction motor and what protection is required to mitigate adverse effect of those faults. Our other learning video of this playlist and other playlists are very useful. You can use them in your studies or refer them to your friends. Happy learning. Have nice time. Thank you very much.